Hello, everyone. My name is Jun Makishi, and thank you for listening to our session, Deliver Your Cloud Native Application with Design Pattern as Code. So I was supposed to make a live spot to ask you some questions about how you take care of infrastructure as a code. But because this is a recording session, I will leave some questions here. Is your infrastructure as code well organized? Do you share your code to other team? Or does your team spend little time on infrastructure compared to application development? Our today's proposal will solve some of these questions. The takeaway of this session is infrastructure as code must solve consistency and reusability for infrastructure manifest and its delivery pipeline. In other words, infrastructure configurations and its delivery pipeline should be managed in a consistent manner. And our answer is design pattern as code, which comes from our production experience. Again, my name is Jun Makishi, a senior architect at NTT Communications. And we will also have Rintaro Sekino, who's site reliability engineer at NTT Communications as well, and he will take care of the demo session later. So before describing design pattern as code, let me introduce our company to give you some context of our proposal. NTT Communications is a global ICT service provider, which has a global footprint to provide end-to-end ICT infrastructure service to customer. These are some examples of our internal projects using the cloud-native solutions. We are shifting more to use software than before to meet customer needs. For example, our operation team has built a cloud architecture to monitor network equipment. Also, there is a SRE team to manage containerized application and its release pipeline. And we are another SRE team to support end-to-end application development cycle. One of the software projects Rintaro and I have worked on is Flexible Interconnect project, which offers an API to let customer control private connectivity between their data center, cloud, and even SaaS. Behind this API, we also use cloud-native solutions. And also we use infrastructure as code practices. So the point was, we have many projects, and we use infrastructure as code at scale in terms of having multiple projects. But using infrastructure as code at scale, we see some challenges. We try to codify everything about infrastructure following the best practice. We wrote many scripts, we have configuration managed by the Git, and we expected the benefits of reusability, consistency, and transparency. But the reality is chaos. We see the more code base grows, the more code got complicated and fragile. There are many project-specific batch scripts baked into the pipeline, which makes it harder to share. Parameter is also our pain point. And as a result, our code got tangled. There are many dependencies between different tools, and we finally are scared to make any changes to a pipeline. So we don't see reusability and consistency anymore. Did we lack discipline? Maybe yes, but I believe it was not the only case. So what we wanted for infrastructure as code, we wanted to write code using software practice, like making a module to share to others. We want one interface for every infrastructure provider. And most importantly, we want pipeline baked into this architecture design. So we propose new way of infrastructure as code named design pattern as code. It is reusable and composable pattern of cloud-native architecture written in a powerful language for a software developer. So what is design pattern as code? Design pattern as code addresses questions about cloud-native architecture, how to deliver a cloud-native application, and how to integrate cloud-native solutions. Design pattern declares all of the infrastructure provider manifest and pipeline. It is a small portion of manifest and pipeline, which is composable with other design pattern. Specifically, we use Cuelang for design pattern, and it consists of infrastructure manifest and delivery pipeline as shown. For the resource declaration, we allow enumerating all of the resource configurations per infrastructure provider. And we also have design pattern declaring tasks to be executed in the pipeline. Those tasks will get assembled to a Tekton pipeline. We chose Tekton because it has a declarative API and each task is isolated from others. As shown in this figure, we compose design pattern tasks into Tekton pipeline. Again, we use Cuelang for design pattern as code. Using Cuelang, we compose multiple design patterns and generate infrastructure manifest. For example, we generate Kubernetes manifest, GCP, Azure, AWS manifest. In addition, we also compose the patterns to generate Tekton pipeline. Cuelang is a powerful typed language focusing on declaring data. It's designed for scale, and it gives us a consistent results composing multiple patterns. So I just gave basics of design pattern as code. So let me give you one example. Assuming we have API server, simple API server running on GCP cloud, the resource configuration could be like this, having ingress, service, deployment, Kubernetes manifest, cloud monitoring, and Cloud SQL GCP resource. This resource configuration can be broken into 3 patterns: base pattern, API pattern, and DB pattern. Let me show how we compose such patterns into a complete manifest. With base pattern, we could have a bare minimum manifest of deployment, as shown here. On adding API pattern, we need to add ingress and service resource, and also we need to compose some parameters to deployment manifest to route traffic to the containers. For GCP resource, we need some uptime check config to check the health of the API. On adding DB pattern, we obviously need Cloud SQL instance config. And also we want to compose Cloud SQL proxy as a sidecar. Running sidecar proxy is a solution provided by Google Cloud documentation. So this is definitely a best practice, a pattern to use Cloud SQL. This means users just need to subscribe the DB pattern to start using Cloud SQL best practice. Next, I will show how we compose pipelines. Having base pattern, we only have this very basic pipeline, building image and deploy it to Kubernetes. On the right side figure, you can see Tekton pipeline definition. I highlighted the task generate manifest, where we compose multiple patterns to generate manifest, as described before. On adding API pattern, we may want to add a task to check API right after the deploy task. And on adding DB pattern, we may want to add backup DB task before the deploy task. Such tasks will get composed into the original Tekton pipeline definition as shown in the right figure. So I have showed design patterns for both manifest and pipeline separately, and the complete API pattern could be like this. It would have manifest and pipeline in the same context. So this is an example of API pattern implementation. As mentioned, we use Cuelang, and in this definition, we declare resource configuration and task configuration. Design pattern could have parameter such as domain name as shown. And in this example, we use this domain name parameter for both uptime check config and check API task. This means on changing this parameter, both uptime check config and the task check API would get updated automatically. This small example shows how design pattern as code help keeping consistency between configuration and pipeline. This is an approach similar to a software development practice to make a small package to pack resource and task in a single context. So finally, it's demo time. Let me hand over this presentation to Rintaro.
Okay. Today, we're going to have a small demo session to describe our design pattern as called core concept. As Jun described in the previous slide, when we launch new microservice, we have to consider not only the Kubernetes manifest, but also public cloud layer resources, monitoring functions, or application delivery flow. So in this demo session, we will describe how tech lead deploys an application with design pattern. Okay, this way. I will show you 2 steps demo. First step, just deploy an application. And second step, deploy application and export API endpoint and create monitoring functions. After this demo session, before that, let me share my screen. This one, I think. After demo session, the API application is working with this endpoint. This is not working right now. And also add the uptime checks, Google uptime checks to this page. Okay, go to the simple application repository. This is a demo application repo. Then target application is simple Flask app. This one. This just responds hello world for the user API request. This one. And also, I will show you app.q file. App.q file is kind of manifest file to define which design pattern you want to use. In this file, you can declare application specific input parameters like GCP project IDs and GK clusters information for application deployment. And also, most important point is you can see deployment Kubernetes manifest specs, and also Tekton pipeline specs for container build and deploy application tasks. Okay. Anyway, let's generate Tekton pipeline using this design pattern. Okay, let me follow this README, copy, and go to my screen. Oops, sorry. And anyway, just run generate Tekton pipelines and apply it. And let me run first. Tekton pipeline run. Okay. Okay, then let me share you a little bit this generate Tekton pipeline shell. Okay, this is just simple shell script and Docker running container, Cuelang official image, and specify which resource type. This time specify Tekton pipeline. And specify application divisions and design pattern division as well. Okay. Okay, then I will show you okay script, and let me go to the Tekton dashboard to show the what Tekton resources are applied. Okay. I think you can see container build task. This task is optimized for our environment, so developer can build containers with tuned container build environment. And actually, we leverage the build kit and using local cache like this. And also, this one, deploy Kubernetes. Then I will show you the compile step. Okay. Actually, in this previous shell command, we generated Tekton pipeline resources. However, in pipeline, compile task generate Kubernetes manifest of application based on design pattern. I will show you, this one, I think this is actual Tekton task step and specified up.q file and output YAML file. After that, generate Kubernetes namespace and also deployment. This is really simple design for demo. In actual design pattern, you can add readiness and readiness proof, or adding add annotations or specify tolerations based on your application requirement. Okay, let's move to second step demo. Okay, current manifest does not deploy ingress and service, so we have to update design pattern to expose API endpoint and add monitoring functions. Okay, let me show you what to do. Okay, let me change our branch check out to testing. Okay, at first generate Tekton pipeline as same as previous version, and also run it at first. Okay, then pipeline just kicked. And before I go to Tekton dashboard, let me show you a little bit what the new stuff. Okay, this is a diff. You can see the import new design pattern, TCP API, and added new input parameters to specify the global IP name or domain name. And also this is just binding parameters. And at last, added uptime check config. Okay. Then let's go to the Tekton dashboard again. This is still running. Actually, the build image part is totally same with previous one. And deploy Kubernetes is now just started. Okay. Working. Okay, just compiling now. As you can see, the compile part is totally same. Actually, revision version is has been updated. Then you can see generated new Kubernetes manifest. Okay. You can see new deployment, new Kubernetes manifest. You can see the ingress part. And with the annotation Kubernetes ingress and specify global static IP specification. And also the service part, you can see service resources and our annotations for Google Cloud Network Endpoint Group. So as you can see, the new design pattern generate these kind of update. And also you can see check API task. So this means the new design pattern also update the Tekton task as well. And create uptime checks resources and check API availability. Waiting the API works fine. Then it looks this pipeline worked fine. Then let me check the application status. Okay. Hello world. This means the new design pattern is working fine and endpoint works fine. And also check the uptime checks. Let me reload. Reloading. Okay, you can see KubeCon demo app. Actually, check status is have not run yet, but I think this takes a few minutes. I think maybe it will be fine. Okay, this is one of the design pattern user scenario. I think that's all my demo session. As I shown at the API endpoint and create uptime checks resources by just change design pattern. Okay, as you shown, the API endpoint is working fine. You can see hello world. And also you can check the uptime checks. Oh, reload. Okay, you can see KubeCon demo up, then all status is green. Okay, that's all my demo session.
Right, so thank you for the wonderful demo, Rintaro. The point was that user just subscribe the API design pattern, and then user can easily expose its application's API to customer. This implies that design pattern could be written by a different engineer, like the one who is specialized in the Google Cloud specification, because it requires some uptime check config and some other load balancer specifications. And user just can focus on the Flask application in this demo. So this means that we can apply this scenario to the many other cases. For example, we can apply this into the security scenario, having a dedicated security team who can just focus on the design pattern for the security and enforce the security policy, like having a security check scanning or container vulnerability check scanning and others. In addition, we can also apply this design pattern to observability. We can have another team who can write a design pattern to establish a monitoring use case, have some agent to collect the metrics, telemetries, and send it to some backend. For example, we can have some design pattern per monitoring backend like Datadog or maybe Stackdriver, CloudWatch, and so on. And also we can use this design pattern to just swap the platform. We just need to prepare design pattern per platform. And if you want to just move your application, you just need to swap the pattern to the other platform. So I think the design pattern has many potential. And let me add more about design pattern as code. So design pattern as code is a new interface for maximizing product value stream. It is to write infrastructure as code with a software practice to scale. And also it includes pipeline to architecture design. And design pattern as code let developer reuse well-architected patterns and reduce infrastructure management cost. As a result, developer can focus on its application business logic more before. Well, design pattern as code is one of the implementation of the idea of configuration as data, an approach to generate configuration in a pipeline. But design pattern as code is unique because it covers pipeline as well. I must leave note that design pattern as code doesn't solve every problem around infrastructure as code. Design pattern is a new interface, new tooling, but to use it in the production, we believe that it requires another layer to do the state management. So we, NTT Communications, have built a new platform on top of design pattern as code. State management, which I described in the previous slide, is already built in this platform. And we also automate all of the operations around using design pattern as code. For example, parameters handling. So as a result, our platform let developer easily subscribe patterns and truly focus on their application development. Oh, and I need to mention that this platform is only used for the internal project for now. But if you guys are interested in, please reach out to us. At the end, we propose design pattern as code. It is reusable and composable pattern of cloud-native architecture. Design pattern as code includes both manifest and pipeline and solves consistency and reusability for those pipeline and manifest. Thank you for listening to our session. And if you guys have any questions, feel free to reach out to us at Twitter. We are happy to have some discussion about infrastructure as code in general as well. Thank you. Okay, so it's live QA session now. Thank you for listening. Let me pick some of the questions we have here. Let me see. Maybe this one. I'll first publish the answer to public to let you guys know that all the users know the question. So the question is, About the design pattern as code, is it only for the Kubernetes, or maybe, or it can take care of the other infrastructure? And the answer is it can take care of the other infrastructure like ZCP, as Rintaro showed in the demo. Though the demo was was a huge delay on the demo. So, but there's a note that here that our approach is currently only for declarative API. As far as it has a declarative API, it should be able to take care of those infrastructure deployment by design pattern as code, because we just need to build the declarative API using the Cuelang and compose it, and then we can deploy it. So yeah, so the answer is we can take care of the other infrastructure, and the ZCP is the one use case we already showed. Okay, that was the one question. And let me pick another one and hand over to Rintaro.
Okay. Okay, let me pick number 12 question. The question is that did you consider Argo over Tekton? Yeah, actually, I know that Argo is a great OSS application, but at this moment, the answer is no, because the Argo is the kind of the full design, the application deployment logic. I mean, the deployment logic is I mean, Kubernetes side has deployment logic, but our approach is that we are leverage Tekton, and we can define and we can customize our specific deployment logic, like taking daily backup or loading upgrade based on the application requirement. That's I think the difference, very different point. Okay.
Okay, thanks, Rintaro. Let me pick another one because we still have some time. Here is another question I published to public. So the question is, are the pipelines for deploying and deploying infra code or for deploying app itself? And this is a great question because the answer is both. Our approach is to take care of both the generating the infrastructure as code from design pattern and deploy it to the Kubernetes. It means deploying the application itself. And as I answered before in the previous question, the design pattern as code can take care of both Kubernetes and the other infrastructure layer. So as a result, our approach will take care of generating the infrastructure as code for both Kubernetes and the cloud infrastructure layer, and deploy the application on the cloud infrastructure. And this can be so using the Cuelang, we generate the declarative API for both deploying, how to deploy the application, how to configure the infrastructure. Okay, so that's the answer. And Rintaro, would you like to go next?
Okay, let me pick number 39.
I think that's the last one.
Okay, the question is, does it support Terraform project? That's a very good question. Actually, we love Terraform and we are actually still using Terraform. But actually, in our internal project, we are using Purmi. Purmi is, Purmi can be used Terraform provider. Then the answer is we still using Terraform, but we want to migrate to Purmi because it's more programmable interface. That has more programmable interface.
Okay. Hold on. So I think it's time to finish this session. And thank you for joining the session. And feel free to jump into the Slack channel that we are still online to answer the remaining questions. Thank you.
Thank you. Bye.